Welcome to Firing Line. I'm Michael Kinsley of the New Republic magazine. For almost half a century now, America has been vaguely wondering what to do with the radioactive waste that's been piling up at nuclear power and nuclear weapons plants. Almost all of it is sitting, temporarily, near where it was produced, awaiting a better idea. Congress has ordered the Department of Energy to come up with this better idea by the year 2010, by which time there will be over 50,000 tons of the stuff. Nuclear waste disposal is a classic NIMBY problem, meaning not in my backyard. Everyone agrees it must go somewhere, but no one wants it nearby. The government thought it had persuaded Nevada to allow a radioactive waste depository at a desolate place aptly named Yucca Mountain. But now the state is refusing the necessary permits to get the project started. Any place on land is going to face similar problems. Shooting radioactive material out into space is impractical and dangerous. That leaves the ocean, 70% of the Earth's surface. One of Mr. Buckley's guests today is the foremost exponent of the view that the ocean offers a solution to this seemingly impossible problem. Charles Hollister is a senior scientist and vice president of the Woods Hole Oceanographic Institute in Massachusetts. He's got his eye on an especially deep part of the central North Pacific. This area has two advantages. First, it is geologically the dullest place on Earth. For 65 million years, while mountain ranges have come and gone elsewhere, nothing has happened there at all. Second, the ocean floor there is covered with a thick coat of especially sticky mud, the consistency of peanut butter. The idea would be to drop missile-shaped canisters of nuclear waste and let them bury themselves in the mud. Mr. Buckley's other guest is Arjun Makhijani, who is president of the Institute for Energy and Environmental Research in Washington. Mr. Buckley, you're legendary as an aficionado of peanut butter. Are you prepared to see it profaned in this way? Creamy or nutty?
I'm not sure you really want to profane it. You're simply pointing out to a further use of it. But let me begin by saying this, that I'm a little bit puzzled by reading some of your papers, because it seems to me that you are adopting, in respect of the word solution was used, a more tentative tone in 1991 than you were using in 1973. Does this suggest that there have been some, that in the course of your researches, there have been some misgivings that arise? But I'll tell you what to do. Let's begin by your outlining, as you did to me one fascinating day last summer, what you consider the correct approach to be.
Well, Bill, one of the things that's really important to remember is that the politics of such an option, to me, have really become difficult to deal with. And I've learned since 73 to 91 that the science and the technology often becomes almost irrelevant in the face of political problems, such as who owns the seafloor beyond 200 miles. But let me back up and say that the concept that I started absolutely, totally innocently at a party in Washington, D.C., when somebody said, we're going to be thrown out of Lyons, Kansas, because nobody wants this stuff in Lyons, Kansas salt bed. I said, what is this stuff? And they said, well, it's plutonium and cesium and strontium. And I said, that's the same stuff that we exploded in the atmosphere in the 60s when we were doing our weapons testing, isn't it? And I said, yeah, it's basically the same stuff. And I said, well, that stuff has gone into the ocean and settled to the bottom onto this carpet of thick, peanut buttery-like clay, and it sticks to the clay. And I knew enough physical chemistry from graduate work that I knew that the positive ions of plutonium, cesium, and strontium loved the clay.
If they're negatively charged.
The clays are negatively charged, and the little things that float down from the weapons testing are positively charged, and they hang on. Now, I was at the time, for reasons, I don't know why, but I was studying the mixing rates of worms in the deep sea. Really exciting stuff, right? How deep do the worms actually bury, like your garden?
Don't bother to tell us, because...
It turns out it goes about that far. But you know how I found out? Because I I saw the worms mixing the radionuclides, plutonium, cesium, and strontium, down into the mud. And I said, that mud loves that stuff, because a complete inventory of what went off in the atmosphere is sitting inside the mud, not on the surface, not in the water, but caught up in the mud, and the worms have tilted into the surface. So I said, it seems very simple to me. Gentlemen, just take this nuclear waste and stuff it into the mud, and unless the field of gravity reverses, that stuff will stay there.
Okay, now stop right there. Do you have a problem with what he said so far?
Yes, actually, a lot of the radioactive materials which were exploded in the atmosphere from nuclear testing, I think you will agree, didn't settle to the bottom of the ocean. A lot of them are on land, and in our food chain, every time you eat, you get some of that plutonium. And my institute actually has done a recent book called Radioactive Heaven and Earth, in which we calculated that over the next century or so, there will be 400,000 or more cancers, fatal cancers, as a result of what is still on land and in the food chain and in the air.
But he's not talking about putting any on
That's
land.
right. I just wanted to make that peripheral correction. The science of deep ocean disposal is not yet fully proved. Radioactive wastes are a very difficult kind of engineering problem. We have to try to predict for 250,000 years. We've never had that kind of engineering problem before. And so on land, where we've investigated these problems, we found the more we look at it, the more complex and difficult that predictive problem becomes. And that's one of the engineering challenges. One of the attractive things that Dr. Hollister is saying is precisely that nothing has happened for 65 million years there. And so this is something that's truly worthy of exploration. But I myself don't think that we know that it is the solution.
Well, in other words, you would accept the postulate that this is the ideal receptacle, but you don't know about things like migration, a term that you introduced in your last paper. Is migration going to be something that we have to worry about 1,000,000 years from now?
Well, actually, what I am really excited about, quite frankly, is that the migration rates of these radionuclides through the clays is less than the rate of accumulation of the mud out there, so that it doesn't appear that there's any physical, chemical reason for the radionuclides to ever reach the surface if you stuff it in 20, 30, or 100 feet into the mud itself. And to me, the key is predictability. And as you correctly point out, the key is going to a place where nothing has happened for the past 60 or 70 million years. Therefore, the next 500,000 years looks like a pretty safe bet, because the world is basically a probabilistic world.
Okay, in that case, I ask a political question. Given the plausibility of this, what concrete tests remain to be made before the political go-ahead can be secured?
That's a very good question. I think you'd have to agree that the first thing we need to know is how fast do these radionuclides move through the clays. We know that the permeabilities are like 10 to the minus 7 centimeters per second, which is very, very small. We know that the
10 to the minus 7, it means a million, right? 10 million?
No, 10 million. 10 to the minus 7 centimeters per second is a very slow migration rate, in fact, slower than the rate of accumulation. But also the clays, as I mentioned, hold on to the radionuclides, and so if you add that, which we call a fractionation coefficient, to the migration, it turns out that we feel very secure, but there's no test yet. No test. We feel very secure that the radionuclides will, once in the mud, can never reach the sea surface, sea bottom again. But the question is, how do you prove it? And I think you've got to put some nuclear materials into the clays, and then you have to go back 5 or 10 years later and do an autopsy to see if, in fact, our calculations are correct. Because I wouldn't do anything serious until I'd put nuclear waste without a can or without a waste form. I'd put nuclear waste basically almost in liquid form into the clays and let it percolate and see if our diffusion calculations and fractionation coefficients are correct.
Now,
that's one thing that has to be done.
In your judgment, would this allow you conclusively to rule on the safety of this disposal technique?
Well, there's no such thing as perfectly safe. So there's going to be a risk in something. Part of the problem with land or sea disposal is currently we don't have any standards that are agreed upon. A few years ago, the Environmental Protection Agency promulgated final regulations that extended only to 10,000 years, when the National Academy said that some of the maximum doses arise 100,000 or 1,000,000 years from now. So all health protection stops at 10,000 years, as if somehow there's an arbitrary cutoff date. Now, these standards have been voided by the courts. Currently, there are no operative standards for health protection, and yet we live in an Alice in Wonderland situation where the Nuclear Regulatory Commission is allowing engineering standards to be promulgated on the basis of Environmental Protection Agency standards, which are being voided by the courts, and billion-dollar contracts are being let out for Yucca Mountain, Nevada, based on those engineering standards, which are based on EPA standards which have been voided. The biggest problem here, you can't do any of this stuff without money. I think that we are in the stage of considering the problems with radioactive materials is very primitive, scientifically, technically, politically. We don't know whether we have national, let alone international cooperation. We don't have social consensus on these issues. So what has happened is the Department of Energy, which I think is a really unfit institution to be managing nuclear waste, has chosen the path of least political resistance and stuck it to Nevada, which is a politically vulnerable state with senators with no seniorities on any committees, and decided that because it owns the land, that's where they're going to put it. Well, the Department of Energy has been singularly unsuccessful politically and scientifically in managing nuclear waste. In 1970, they said, we will have a repository in 10 years. In 1982, they said, we'll have a repository in 16 years. In 1990, they said, we'll have a repository in 20 years. So they've got a new Murphy's Law. Well, a repository is always 20 years away.
How do you account for that? I mean, on the assumption, and let's accept this assumption, that they're not morons, why don't they read what you write on this subject?
Well, I have to take exception a little bit here. I have some very strong scientific connections with Department of Energy scientists, and the ones that I deal with are clearly not morons. I mean, in fact, they're hiring the students from my MIT program. I mean, they really got some good people there. The problem, I think, is one of ownership of land and the site selection criteria.
Well, why are they interested in land?
Well, if they're going to put it on land,
why are they going to put it in land?
That was what they decided they were going to do at the very beginning, and the train has become very long and moving very fast.
The most recent overall exploration, the only really overall exploration of this subject was done by the DOE in 1974, and there's been no revisitation of all the options in light of everything that we've learned. I don't dispute that there are good scientists in the DOE. That wasn't my point. Of course, there are many. I know many good people in the DOE. In fact, the DOE invites me on to participate and give observations and criticism of some of its programs of late. That's not the point. The question is, what is the history of DOE as an institution? Let me give you an example that you appreciate. When the first draft of the Hanford site characterization, Hanford, Washington State, was one of the potential sites for land disposal. And there was an internal draft produced for the DOE. And the draft was rather more negative than the management of DOE wanted. And they wrote a memo asking the scientists to revise the draft. And they advised that in the revised draft, the use of level 2 language is needed in the text. Never conclude anything. Use double negatives. That, for example, it is not indicated that the following conditions has not been met. Now, I think this is politics out of Orwell, which is independent of science. As another example, when they selected sites in the East Coast, they had an area recommendation report which completely ignored all of the official literature which has been recently produced, not by me or the Woods Hole Institute even, but by the National Academy of Sciences, which the DOE itself had commissioned. The National Academy produced an excellent report in 1983 on land disposal, criteria, doses, evaluation. The most recent reference to the National Academy reports, of which there are a long list, was a 1957 report. It completely ignored USGS studies which had been commissioned by Congress to help the DOE select sites. Of course, they report the disaster, and it had to be jettisoned.
I am anxious to focus not so much on their delinquencies as on the failure to move on your insight. For instance, you did mention the U.S. Environmental Protection Agency estimates that within 20 years, 80% of all existing landfills will be closed. So that's a very finite resource, even assuming that it were reliable. But what I'm asking is, well, let me begin by asking you, how much would it cost to to conduct the experiment you just finished describing?
Let me answer that question by backing up just a few inches and say that for about 13 years, DOE did fund a program that I was one of the senior scientists on that eventually included 8 other countries. And all of these countries signed off on a document that said it's technically and scientifically feasible to dispose of high-level radioactive waste deep in the sediments, the deep geology. We're not talking sea disposal, we're talking about in the geology. And at that time, which was just, say, mid-'80s, the DOE terminated all funding of subsea bed disposal.
Why?
I think it was a combination of the Graham-Rudman kicking in, a new department, a new secretary, and as the ex-assistant secretary said to me, nothing, Charlie, will erode public confidence in our ongoing efforts than if we studied a viable alternative. Well, I said, okay. I said, Charlie, you're a hard-working scientist, and this didn't compute. And I said, as far as I'm concerned, this program is dead with that kind of mentality. And the assistant secretary has since been fired. DOE itself is not just one nice monolithic little shop. It's a constant. It's like a turnstile of people coming and going and coming and going and coming and going. Then the leadership continues to change. And it's like catching mercury with a sledgehammer. It's virtually impossible to get your arms around a Department of Energy, and I feel sorry for them. I really do.
Okay,
but basically, what it would cost.
Yeah.
We had the real problem we were just talking about is confirming fractionation coefficients and diffusion rates. To put that experiment on the bottom is about a $5 million experiment.
That's nothing. In terms of their
compared
budget.
to 800 or 900 million they're spending a year on the land base. To me, it was nothing.
It would take 5 to 10 years?
I think you could percolate the stuff through there in about 3 years, do the autopsy, and really know whether the ion migration rates are right and whether the thermal gradients are right. And I think you would then be able to say, okay, now it's time to really do some serious thinking about it. But it has to be an international program because the geology of the deep sea that's most suited lies way beyond anybody's ownership.
600 miles north of Hawaii.
600 miles, 800 miles north of Hawaii, a couple thousand miles this side of Japan. There's an area up there about 5 times the size of Texas that it is absolutely boring geologically. That's just, it is, you drive along in a ship, you go about 200 miles a day and you take a course.
Well, are you talking about a political problem now, or
I'm talking about the political problem that
not a scientific problem.
I think the scientific problem can be solved by an experiment to determine if our calculations are correct. But the big problem is going to be the politics of, okay, how do you manage, how do you regulate an international repository, an international waters in a geology that nobody owns or everybody
How can you live with a viable solution?
Yes. How do you deal with a viable solution? Apparently, that's not easy to do.
In my opinion, the big problem here, big problems have generally been political and institutional. Of course, the scientific problems are immense.
Oh, sure.
I don't want to minimize them. But so long as we have got an opportunistic engine in place, one by one, we go to Lyons, Kansas, and we suddenly announce this is the best site in the country. A geologist says it's as full of holes as a piece of Swiss cheese. Watch out. It's the best site in the country. You put water in, it disappears. You have to abandon it. Then you go to the next place and the next place and the next place. And right now we're in Yucca Mountain, where the National Academy's study, printed in 1983, predicted that if the groundwater got severely contaminated from the disintegration of glass, which has been confirmed by, that if this happened, and it has been confirmed by DOE-funded studies, that the annual dose rate to people just from the military high-level waste would be 100 rem per year, which is 4,000 times the maximally allowable dose today. So you've got a place, geologists have said, the most important criterion, what Dr. Hollister is saying is the attractiveness of seabed is that it's predictable. It's characterizable. The most important problem with Yucca Mountain, one of the most important problems, is the geology is so complex, is you're never going to get 6 scientists in a room to agree that this place is safe or not safe. So you could, what we are now, and we're on the road to spend $5 billion to $10 billion, and at the end of 20 years, we'll wind up in a place where there will be no consensus. But the nuclear power industry does not want to stop that process because they feel if they stop it, then there will be no more options. There will be a lot of science going on, which is what we really need, but they won't be able to rapidly build more nuclear power plants. So this thing is not being driven by the science. It's being driven by utility. I was in a DOE conference in which a utility executive said, you must take this stuff from us. I don't care where you put it. It's the worst kind of collaboration between big government and big industry where science, they're putting upon the state of Nevada. They're taking away all the rights of the state of Nevada to issue environmental permits.
Well, Mr. Hollister, are you helpless as a scientist, waiting for people who live in the world of politics to push this to a logical conclusion, or is it something which you think the scientific world uniquely can mobilize, a movement to test this?
All of my scientific colleagues, both here and abroad, and there must be now hundreds of us, have come face to face with political reality, which is that it is not in the interest of the Department of Energy to pursue such a option, and have given us all kinds of reasons, and even DOE has said the science is wonderful, the science is unassailable. In fact, I published in Science magazine, an internationally recognized journal, the findings of our team in 1981, and the political reality is such that I think we are hamstrung. I am not, well, this is a good exception. I mean, right here, talking. This kind of exposure, I think, is about the only chance we have to get our message across, to get the politicians and those that jerk the politicians around to think more sensibly. But I just, as a scientist and an educator, I've got a lot of other exciting things to deal with that I think are really important. We've got global change, we have the CO2.
Exactly.
We've got some major global environmental issues, and to me, the nuclear waste issue is not really that important.
One of the difficult...
I don't think so. I think chemical waste in the groundwater, sewage sludge, and other really massive, keep in mind nuclear waste, the total amount of nuclear waste in this country to the year 2000 is only 1% of a supertanker full. I mean, it's not a huge problem. But chemical waste, other kinds of waste in groundwater, that really worries me.
I'd like to differ with that a little.
50,000 tons is nothing.
No, it's actually not 50,000 tons. You're talking about only one kind of nuclear waste, which is the spent fuel, the radioactive rods which come from nuclear reactors. The total quantity of nuclear waste in the country is actually immense.
When not compared to sewage.
Not compared to sewage sludge. But of course, comparing nuclear waste to sewage sludge is like comparing corn stalks to plutonium.
But
I mean, it doesn't compute.
Volumetrically, it's trivial to an oceanographer.
A pound of sewage sludge and a pound of plutonium are completely different things. A microgram of sewage sludge isn't going to hurt anybody, but a microgram of plutonium is going to give you cancer with a very high probability. So you can't really compare nuclear waste.
Asked me what was most worrisome to me.
Right.
Nuclear waste ain't the big one.
Okay, well, it is what we're discussing today, and we're running out of time. I have a question for Dr. Makhijani. You know, most of us listening to this conversation have perhaps shamefully given no consideration to the problem of nuclear waste whatsoever until just now. And we listened to Dr. Hollister's idea, and it sounds completely reasonable.
Right.
What is the attitude of the scientific community towards Dr. Hollister? Is he considered to be a completely out in left field crackpot? Is he considered to be eccentric but promising, or is his idea considered one of several options, or is it considered the conventional wisdom, or what?
I don't think that it's my position to comment on Dr. Hollister. Is much more eminent than I.
No, but just give
Dr. Hollister.
Dr. Hollister is the only man.
No, but I think my opinion is that subseabed disposal should certainly be scientifically investigated and deserves considerably more money than it has.
But what is the conventional wisdom in the industry?
The industry is different from the science. I think most scientists would support Dr. Hollister. I think that it deserves exploration. I think that it's not just a scientific question. There are transportation accidents. Remember the Exxon Valdez. There are many other problems associated with nuclear waste disposal. We also have a lot of other problems than just thinking of where to put it. We today have a completely irrational system of waste classification. We've actually got millions of tons of this stuff sitting around in all the military production sites and no idea of what to do with it. So whether you can put millions of tons, what it will do to the ocean, this really should be, to the ocean floor, this really is very worthy of investigation. It's my opinion that until you have the present program in place, which is irrational and managed incompetently, you can't get good science done.
We
and
don't
that's our biggest
the
problem.
ocean floor, do we?
They don't want a viable option.
The ocean floor is the most useless piece of real estate on this planet. And the nice thing about it is almost half the planet is covered with this mud. So if you need it, we got a lot of it.
You know, what's a useless piece of real estate over 100 years? The definition of that can change over 1,000 or 10,000 years.
Thank you, Dr. Makhijani. Thank you.
We're just getting started.
Thank you, Dr. Hollister of the Woods Hole Oceanographic Institute. Thank you, Michael Kinsley of the New Republic. Ladies and gentlemen.
Next week on Firing Line, host William F. Buckley, Jr. talks with Yale Law professor Stephen L. Carter, self-described beneficiary and at times victim of affirmative action, who argues that it does little to promote racial equality. Funding for Firing Line was made possible by